So if you remember in the last video, I mentioned that there were 6 different basic types of quadric surfaces. And so your textbook has this nice table that we're going to go through and see these 6 different types of surfaces. So the first is an ellipsoid right here. You can think of an ellipsoid kind of like a blimp, and it has this nice equation right here that's kind of a 3-dimensional version of an ellipse equation. And so that's your general equation for an ellipsoid. And I do want to note that when A, B, and C are equal, you're going to get the equation of a sphere. So the next type of surface we had was a hyperboloid of one sheet. And in general, what it looks like is this equation right here. Now notice you'll have your variables being squared, x squared, y squared, and z squared, but one of them will have a minus sign. One of them will have a minus sign. So in this case, z has the minus sign, and because it has a minus sign, this surface goes up and down the z-axis. So it'll go, the axis of the surface here will correspond to whichever variable is negative. So if the y squared was negative, it would go up and down the y-axis. Now, the next type of surface is a hyperboloid of 2 sheets. And if you look at this general equation right here, you'll see that you have 2 of your squared variables having minus signs. Minus, minus, right there. And so in this case, the axis that you can think of these as kind of being like 2 bowls pointing in opposite directions. The axis of those bowls correspond to which variable had the positive coefficient. So here z squared was positive, so this hyperboloid of 2 sheets went up and down the z-axis. All right, so that's the first 3 types. Let's look at the next 3. So here we have the equation of an elliptic cone, and here you'll see that you have 1 minus right here. Oops, sorry. We have 1 minus right here. And it's kind of similar to what you had before, but now before you had equal to 1 on the other side of your equation. Here I have equal to 0. Here I have equal to 0. And so your cone, the axis running up and down your cone, will be the one whose coefficient is negative. Whose coefficient is negative. So if you look here, z was negative, and so my cone goes up and down the z-axis. Okay. Then we have an elliptic paraboloid. This equation looks different than the ones we've seen before because now I have a variable that's not squared. So in this case I had z, but in general you'll have one variable not being squared off to one side and then the squared terms being on the other. And this elliptic paraboloid is kind of like a bowl where if you slice it, it's made up of ellipses. And this bowl, the axis running through this bowl would correspond to the variable that isn't being squared. So here z is not being squared, so this bowl faces up the z-axis. And our very final type is a hyperbolic paraboloid. This one is kind of similar to the last one. You have one term that's not being squared and the other ones are, But now you have a minus on one of your squared terms. And again, your axis corresponds to the term that has the first power here. So here, z is the one that has the first power, so this shape is running up and down the z-axis there. So what we're going to do, now that we have these general formulas, is we're going to try to classify surfaces and say what type they are. And so in order to do that, you're probably going to want to come back to these equations in these tables. So you might want to write down some of these formulas before you go on and watch the next video.